In this lecture, we're going to learn about implicit conversions with references. And to really drive the point home here, let's start by looking at a few examples. Here we have two functions. One is called increment. Let's change this to red. And it is going to take an int reference parameter here. The second one is called printout, and it is going to take a const int reference in. And all these functions have the return type of void, so they're not going to really return anything. They are just going to do whatever they do, and they are going to finish. Let's go down and see how we can call these functions. Here we have two variables. We have an integer, which is called int value, and a double, which is called double value. And inside these guys, we have two values. We have a 12 and a 52.7. Down here, we are trying to call these functions with our int value, and you're going to see that this is going to work fine. You see, okay, here, this says that this is going to compile fine, and if you run it, you're going to see what you expect, because we are passing an integer n. But when we happen to pass a double n, and remember, these functions were taking references to int, you're going to see that the calls to print out here are going to work, but we're going to get a compiler error if we pass in our double value here. And we're going to analyze why this is the case. The first case we're going to look at is the case where we are passing in const references. And we have seen that this function was working even if we passed in types that are different from int here. Here we're going to suppose we have a double variable. We're going to call it double var, and we're going to put in, for example, an 11.5. Let's do that. We're going to put our semicolon here, and we're going to go down and call our function with our double variable. Let's say print out, and we're going to pass in double var in here, and we want to see what is going to happen. Well, the compiler is going to notice that what we have here is a double type. And our function here is really taking a reference to int. The compiler knows that it will need to do some kind of transformation to really get this argument that we are passing in here ready to be used in a function like this. And what the compiler is going to do is to set up a temporary variable, and the temporary variable is going to be of int type. Let's say that here. And let's change the color and say that this is going to be a temporary. And when it set up this integer temporary variable, it's going to make a transformation from this double argument we have here, and it's going to turn that into an integer and store the value in our temporary here. So let's change the color to red again and put in an 11 here, because that's going to be the value we get. We are transforming from double to int, so we're going to lose data. We're going to lose the decimal point and store an 11 in here. Once we have this temporary, we're going to pass a reference to this temporary in the function here. That's what the compiler is going to do. It's going to pass a reference to this temporary. And once we get inside, we're going to print whatever value is stored inside, and we're going to get an 11 printed out here. That's what we're going to get. And this is how the compiler works. But notice that the compiler is going to set up a separate temporary variable to store our transformation from double to int here. And this is key. And this is really going to work because we are not trying to modify this reference here. And if we try to do that, the compiler is going to stop us because this is a const reference. Okay, this is how this is going to work. Now that you know how this is going to work, we're going to analyze the case where we are not passing in a const reference. Okay, we are going to look at this example here. We have our increment function. The increment function is taking an int reference, and we're going to set up our variable again. So we're going to say double var, and we're going to put in 11.5 like we always do. This is how it's going to work. And we're going to say increment, and we're going to say double var. When we do something like this, the compiler again is going to notice that we are passing in a type that is different than what we have in our parameter. We are passing in a double, but the function is going to take a reference to int. So the compiler knows that it has to set up some kind of int somewhere and do the transformation. And it is going to do just that. It's going to set up a temporary variable. The type is going to be int, and it is also going to be a temporary. Okay, let's say that here. The compiler is going to insert the transformation from double var to int, and we're going to have to store an 11 in our temporary variable here. And the compiler is going to pass a reference to this temporary in the function. This is much more fitting for the type we have in here. So that's what is going to be passed when the function gets called, a reference to this temporary here. Now, notice what we do in the body of this function. We are incrementing this guy, and we are incrementing a reference to this temporary. Once we do that, this is no longer going to be 11, it is going to be 12, let's say that here. And now we have two variables. We have this temporary here, which is storing a 12, and we have the original variable that we passed as an argument to this function. So who is really going to store the final changes? Is it this temporary here or this original variable, which is a double that we passed as an argument? And this is really confusing, and the compiler is going to stop you from doing this in the first place. Okay, so this is what is going to happen if you have a function that is going to take a non-const reference and you pass a different type as an argument. The compiler is going to prevent any kind of implicit conversions because that would lead us to this kind of confusion we have here. And that's why we have the compiler error that we saw when we tried to pass a double type to our increment function here. So we're going to head over to Visual Studio Code and actually see this in action. Here we are in our working folder. The current project is Implicit Conversions with References. We are going to grab our template files here and we are going to put them in place. The current project is Implicit Conversions with References. We are going to open this in Visual Studio Code. Let's do that, 1719. And we are going to have our main CPP file here. Let's clean it up a little bit. We are going to close this left pane. We don't need it anymore. And we're going to go down and put in our two functions here. Let's close the terminal for now. We have two functions here. One is increment. It is going to take an int reference. The other is printout, which is going to take a const int reference n. These are definitions we just put below the main function here. Let's go up and put in our declarations pretty quick so we can copy from our definitions here and do that. We are going to go down and put in the declaration for printout and put in our closing semicolon here. Okay, we have the functions n. What we can do now is set up some int variables to really play with us. We're going to head over in the main function and set up an int var variable, and we're going to initialize this with a 3, why not? And once we have this n, we're going to use this to call our functions. We're going to say increment, and we're going to say int var, and we're going to say printout. And you notice that we don't get any problem here because we are using an int, and our functions here take references to int. So this is going to work as we expect. And if we run this application, we're going to see these guys print out. Increment is going to increment and say value incremented to 4 because we had it in a 3. And if we print out, we're going to get a 4 printed out. So this is nothing special. It's not going to give us any problem. Let's try and build this and really show you this. So we're going to use GCC. The build is going to be good. We're going to clear and run rooster. And we're going to see that value incremented to 4 and value is a 4. But we might have a problem if we try to call these functions with a variable of a type that is different from int. Let's do that. We're going to comment this out and show you how things can go wrong. So we're going to set up a double var and we're going to initialize this with 3.6. Why not? We're going to use this to call our functions. So we're going to say increment, we're going to say double var. And we're going to also print out double var. And at the moment we do this, you see that we get a compiler error on our increment function here, because this would lead us to the confusion we saw in the slides. The compiler is going to stop us from doing something like this. And if we really want to pass this double var, the only option we have is to cast it to int ourselves. So we can come in here and say int data, for example, and we can assign double var. Then we can pass in data, and this is going to work. This is going to do what we want. You see that the squiggly line goes away because we did the cast ourselves. So this is something you need to be aware of if you are relying on implicit conversions and using references, because this kind of compiler errors can really be hard to find and solve. And this is really all we set out to do in this lecture, to show you the problems you might come across if you are passing parameters by reference and you're not careful about the const you have in here. I have to say, I don't really like this about C++. I don't think they should even allow people to use implicit conversions if you are using references like this. Because if you use a reference, you know that it is going to be a true alias. And if it is a true alias, why do you give me an option to pass a different type than what the function is taking? This is going to lead to a few confusions, but we don't live in a perfect world, so we have to live with this. We just have to be aware of these problems and learn about ways around them if we come across them in our daily life as C++ developers. We are going to stop here in this lecture. In the next one, we're going to learn about implicit conversions with pointers. Go ahead and finish up here and meet me there.